Good afternoon, everybody. I've been informed that this video is being recorded, so all of my off-the-cuff wit is going to have to be tempered a little bit, so hopefully we can crack some jokes after the recording goes off. If you've been in any of my sessions before, I like to kind of have fun with these things. I hate just talking at people, so if you feel free to ask questions, or if it gets to the point where the question gets too deep for the answer, the amount of time we have, we'll kick it to the end. I think that we'll have maybe 5-10 minutes or so until the end, or when we run out of time, so hopefully we can answer some questions there as well. But let's get started. My name is Harlan. I am what am I these days? It's actually hard to say. My title is a Premier Field Engineer, but I kind of do a couple different roles. One role is, if you're familiar with Premier, has anyone used a Premier Field Engineer in the past or had a contract with Premier? Okay. So you're familiar with it. You're probably used to the model of either you needed someone for a very specific and small term task, or you had an entire engineer dedicated to just you as a customer under X workload, SharePoint, OneDrive, whatever. I still do that. I have a small customer set that does that, but now I actually manage a team of, we call it a pod. So we look at it from the perspective of no more of just one person supporting one workload. We have an entire team dedicated to an entire customer, and we just have more customers and we split the workload that way. So now you essentially get an entire Office 365 group of engineers versus just one. That's an easy way to say it. So I'm both technical and a technical manager at the same time with no direct reports, which is kind of nice. I also do what's called strategic technical advising, which is essentially the Premier version of an architect, right? So I do strategic planning for customers. Among other things, obviously I've been here at Microsoft for 10 years, which is kind of crazy. And if anyone's ever been to a SharePoint Saturday, that actually started with myself and two others about 10.5 years ago. So that's been going for 10.5 years too. So a lot has happened in 10 years, and a lot has happened with the way that we do disaster recovery for SharePoint on-prem, and even bleed over into some of the online world. So that's what we're going to be talking about. We're going to be talking about the Azure Site Recovery feature within Azure as it relates to SharePoint, at least in the context of our conversation on-prem, but you can sort of take the scenario and broaden it pretty far pretty quickly. So I think it's important to at least set the stage of what I and most experts consider a disaster, right? So a disaster is when you actually lose your service. It's done, your servers are out, you have no connectivity to data center, database is gone, whatever it is. So you lose connection to your service, and you could possibly lose data in the process, or a subset of those two. Maybe because of the service being down, you're losing data, or you've lost data as part of the disaster itself. So a couple combinations of those, and I think that's important, and I'll tell you why I think it's important in just a little while. Typical recovery times depends on the workload. This is a pretty general statement, but it's about 1 to really 9 is not really a good answer. It's really 1 to however many hours it took for you to be best prepared to recover from those kinds of situations. I deal with a lot of this in my day-to-day only because of my background in Azure and in some of the SharePoint workloads, and I've seen weeks for recovery time. I'll tell you some of those stories with withholding some of the names, obviously, as we go. So just the general consensus of loss of reputation, brand stability, whether that's internal, right? So we can look at this from an internal perspective too. How many people in this room, I'm sure, have had the trouble of standing up SharePoint and then no one using it? Maybe in the earlier days, that in itself is a brand. You're branding the internal structure of a service and its reliability and usability in your organization. Or, obviously it can be broadened out to, the external public and people actually hitting those services. Loss of revenue. And then loss of just critical internal business services, right? If your SharePoint environment is the system and the mechanism that you use to keep track of HR documents or legal holds or whatever it might be, and that's down, obviously the business as a whole suffers as well. So there's a lot going on. Disaster sort of encompasses quite a few things. So when we talk about what is actual true disaster recovery, how do we quantify that, right? True disaster recovery, we look at it from the perspective of how fast can I recover in an outage, and what along the way of preparing for an outage or preparing for a disaster makes it easier for me to make sure that I know this system will work. So the two big inhibitors for making sure that these things work is it's hard. It's really hard in some cases to test a DR strategy if you don't actually have a service applied to that strategy. If your strategy is, we have an outage, we pull backups, we start, pulling tapes, reloading our SQL databases and connecting things back up that way, your time and complexity is going to be way out. But the cost is way down, depending on if you're not losing, revenue as a result of the outage. When you talk about other systems and other third-party vendors outside of Azure and Azure Site Recovery, we talk about how easy is it for us to test whether we're in some kind of compliance thing that we have to test maybe every quarter, every year, once, twice a year, whatever it might be. What's the process actually look like? So we talk a little bit along those lines of how simple it is when something actually does happen. So the good thing about Azure Site Recovery is it's essentially one button failover with minimum or almost zero data loss depending on how you plan it, and as most things, depending on how much money you want to spend on it. In this, setting the stage of what we're going to talk about, it's important also to talk about RPO and RTO. So it's pretty self-explanatory. How much time are you able to be down, and how much data are you willing to lose? And those in itself, I promise you, drive the cost factors, drive the decision-making process with leadership on how your disaster recovery plan is actually going to be in place. If I promise you, going into the conversations, it's going to be, well, we don't want to lose anything and we don't ever want to be down, right? So that's typically how it starts. And then you start saying how much that'll cost, and then it starts backing up from there, right? So whatever that number ends up being, you have to, in an SLA form or whatever the agreement process is, set in stone how much time are we able to be down, and how much data am I willing to lose, both from not being able to capture data as a result of the service being down, but also, again, just losing stuff, which often happens, right? So these are the two things that actually will dictate cost, planning, complexity of this whole thing. If you have unlimited budget and you don't want to lose anything, and you have a great network and you want to spend quite a bit of money in Azure, you can essentially achieve almost zero in both of these cases. So it really just depends. A couple disaster recovery scenarios, some of which I've actually seen, which is kind of strange. I've actually seen burst sewage pipes that were, for some reason, someone's wisdom, run over top of a data center, literally through it, and then back out. Those broke. I can assure you I wasn't going to be the one going in there switching out racks. I've seen air conditioning and the generators that power the air conditioners, and then the generators that are supposed to back up those generators, all go out in Texas in the summer, where they were literally pulling hard drives out of racks. Literally, just pull. I mean, of course, nothing's going to work at that point. Your data's gone, but you might save the hardware, I guess, is the thought process there. Very typically, it's either these days going to be someone who just selected next too many times without actually reading the prompts and understanding what they were doing. And we've had a rise of scenarios like around ransomware. So you haven't seen this in the news, I promise you, but I work with a customer who lost everything to ransomware. Completely gone. Everything. They didn't want to pay what the ransom was, and they thought tapes were a good backup strategy, and they come to find out that they haven't tested any of the tapes, so everything was gone. The discussion around going to 365 became a lot easier that day, but those are scenarios that actually happen. The other two, well, I guess maybe just one outside of disaster recovery in itself that I see a lot these days is the idea that, what did it look like if we wanted to move a SharePoint environment, for example, from a data center in the past, let's say, 8 years ago, 10 years ago, to another data center? What did that physically look like? If it was VMs, we could manage that. Sometimes we actually had to stand up entire new farms, make sure the patch level was correct, make sure all the CUs were correct, make sure all the networking was correct, and then do database mounts back into the SharePoint environment to essentially move that workload. Nowadays, the curve of cost and feasibility is matching in such a way that where we had organizations that never had data centers, that's an easy, okay, yeah, of course we're going into Azure because, why would we stand up a brand new data center when it's cheaper just to do it this way? But we're actually seeing it now where customers are getting off of on-prem or rented data centers and moving into Azure. I'll admit it's low, right? I think the ratio of people going from SharePoint on-prem just into SharePoint Online, for example, is much, much higher than people staying on-prem from a deployment perspective and just moving data centers. But this scenario that we're going to be talking about today is actually a really good scenario for moving from one data center to another data center without actually having to do any of that work that we used to have to do with mounting databases, moving servers, patching, and all that stuff. So these two scenarios, just DR as a whole, and then that lift and shift, are the two that I see ASR use for the most in my role. Just quick show of hands, is anyone actually using ASR today? Or, okay, so a couple. Has anyone seen it and played around with it? Okay, a few more. Okay, so we're gonna talk about what it is. It's probably a good level set, right? Let's talk about what actually ASR is. So Azure Site Recovery is a way to essentially replicate a couple different systems, and it really just breaks down to three main categories. VMs, bare metal, so Hyper-V VMs, VMware VMs, and then bare metal. Right? So we can take these systems and replicate them over the wire into Azure, store them in Azure storage off, stand up all the mechanisms that we need in place to actually do a failover, and then when we actually have an outage or when we want to test a failover, literally click one button, after it's all said and done obviously, one button to failover or test failover, and Azure Site Recovery will pull all those things out of storage, take all of your network configurations that you've already done, stand up those VMs, and you actually have all of your traffic now going from what was your on-prem state over to Azure Site Recovery, well, essentially Azure IaaS at that point, right? So it's infrastructure at that point. It doesn't matter where it's actually installed, right? So Azure PAC, we can use Azure PAC to go from data center to data center. It doesn't even have to be in Azure. It's just a service that's built on top of Azure. Okay. So these are some of the ones that we currently support and manage. The ones that we talk about today will be mostly around Hyper-V and bare metal. The scenario is essentially the same with a slight few nuances. I'll talk about them as we go through. I'm not going to pretend like VMware doesn't exist, right? A large majority of folks use VMware. The good thing is the experience is almost identical. So regardless if I show you Hyper-V today, it's exactly the same thing for VMware. There's one little additional configuration piece, and that's it. So we talk about Hyper-V to Azure. We talked about data center to data center. We've talked about site to site, whether that be outside of a data center. We talked about Hyper-V, VMware, bare metal at this point. These also apply to just individual workloads too. It doesn't have to be SharePoint running in a multi-tier load balanced environment. This could be a database that powers some app somewhere. This could be Linux servers. This could be a variety of different things. Essentially, it's your entire data center or applications or products or whatever it might be available to be backed up within Azure and then turned on when you need them to be. So we go deep into some of the planning things because quite honestly, setting up Azure Site Recovery is pretty easy. It only takes maybe 20 minutes of configuration outside of the cost time-wise of just getting VMs up to Azure. But a lot of it comes down to the prep and planning, which, I mean, at this point with SharePoint, I think we're all essentially used to, right? It was a lot easier to stand up SharePoint back in the day without actually doing any planning, but we found that planning was 90% of the actual work. So we have to take into consideration, first and foremost, I'm sending a large chunk of data to an Azure data center. What does that look like? How do I need to plan for that? A couple things that we do that make things much easier. So we have a lot of optimization built into just the Azure Site Recovery process server, which doesn't mean anything at this point. If you haven't seen Azure Site Recovery, I'll talk to that in just a bit. So there's some optimization for just data across that wire. We support third-party products like Riverbed. We've actually seen a 72% reduction in just data being sent over the wire, whether that's site to site, just over the internet, or if you're using things like ExpressRoute. Obviously, ExpressRoute would be a good thing here. The first time you actually set up Azure Site Recovery and you do your first data sync, that entire chunk of data has to come across. You can delay it, you can set up happy hours, you can throttle it, you can even adjust how much network saturation you have. It's totally up to you, but at some point we have to get the VMs over for the first time, okay? Every time after that, it's only the deltas of what has changed from the time that I last did my sync to what I have in Azure storage. That might be kilobytes, that might be gigs. It sort of just depends on what the service is, right? So that's totally up to you, but you can manage that from that perspective. As well, the virtual size of a VM is not what we actually pull across. I mean, that seems like common sense, right? But we have to at least call it out. If the VM disk size is a terabyte, we're not actually pulling a terabyte across the wire to reserve that. We're only pulling what the actual data constitutes within that VM. So if it's only 20 gigs, that's all we're pulling over the first time. So like I said, we have the ability to change and direct how much we saturate our network with those data syncs for the first time, and every time after that for that point. If you do have ExpressRoute, so ExpressRoute, if you're familiar with it, it's essentially a direct line from your data center, your office, wherever you're pulling from, to Azure. It requires a third-party vendor and a physical pipe in some cases, but it's a direct line from you to Azure. In some instances, people and organizations will have multiple express routes from multiple geographically dispersed locations, all going to an Azure data center. Obviously very expensive. In my opinion, it pays for itself in the long run. Things get real dicey when you start talking like your Azure Site Recovery on-prem SharePoint environment with a hybrid environment extension to Office 365 and ExpressRoute. Those things get a little bit shady, but just getting data from your location up to Azure, ExpressRoute is a really good option if you have the cash, obviously, to spring for it. We have the ability to decide how much saturation across, let's just use ExpressRoute for example at this point. Whatever the pipe is, it doesn't really matter. We have the ability to say, I only want you to run at this capacity or this lean. I want you to run, this hungry. Maybe we're off hours and we need to do a huge data sync. Fill up the pipe as much as you want with this synchronization. It's totally up to you to configure. Like I said, you can set up happy hours to define when you're doing these synchronizations. You'll probably want to do them off hours or whatever the best convenient times actually are. There are a couple different ways that we can manage the way that we direct data from your on-prem location to Azure. We'll talk about that here in a second. Obviously, having a direct line to an Azure data center is going to be much faster than if you're just going over the internet. It's going to be obviously more secure, right? We can get those right out of the way pretty quickly. We also have the ability to define the channels in which that data is being processed across, right? So we can say, okay, for bulk data transmission, I want to use a split within our express route that we call public pairing. When I do things like have folks individually connect to a service within Azure, I can define that down to something a little bit more secure we call private peering. So there's ways to define even the channel of data that you're sending up into Azure and how people are accessing that content once you've failed over into Azure, okay? It obviously works as an extension of your network. No one will ever know that you're hitting your express route, you're going up to Azure. In some cases, customers don't even know when they've been failed over. It happens so quickly, right? So if they weren't intelligent enough or cared enough to look at the IP addresses, you would never know. It would just fail over, and you might see a couple second latency, and then SharePoint's back up and running. So it really just depends on how you architect it and what all the network capacities are prior to you actually doing a configuration for ASR that defines what that user experience actually ends up being. So I'll leave this up for just a bit so you guys can kind of take it in. There's a couple different things that you have to take into account with ExpressRoute. I know we've talked about it with a couple slides, but it gets way deeper really quickly. So I'm going to leave it sort of high level, at least so you guys understand that there's a couple different ways to access content from on-prem to your Azure data center. So you can do site-to-site VPNs as well. So site-to-site VPN is a function within Azure that you create that essentially extends like a VPN your location up to Azure, and you can send data that way. So it's secure that way. It just takes longer, right? There's a couple different requirements you actually have that run the VPN on your side. So there's a couple machines that you'll have to get created, but the cost is thousands and tens of thousands of dollars cheaper essentially at that point. So it really again depends on what you're pushing, what criticality the workloads are. Obviously there's a bunch of different things that go into account there. Some of the things that we have to take into consideration were just Azure Site Recovery as a whole and making sure that we have all the I's dotted and T's crossed, right? I fell into just one of the limitations when I was doing this demo with the fact that you actually have to have Windows 2012 R2 or above on the machine in which you're doing some of the installations to actually have this work. You can't create a demo box on Windows 10 running Hyper-V and set up Azure Site Recovery, unfortunately. I thought about ripping out my my hard drive, but that'd have been a ton of work. So some of the other limitations that we come into are really just dictated by the location and the current physical state of the workload and what we're doing with it in Azure. So a good example is when you go Hyper-V. So Hyper-V Gen 2 VMs are actually not supported, right? So how do we do that, right? So you don't actually have to do anything. When you do your failover, we will convert your Gen 2s to Gen 1 like nothing, right? Nothing ever happens, nothing's running that you need to account for from a configuration perspective. We just convert them, stand them up. When you do a fail back, we actually convert them back to Gen 2. One of the things that you have to take into account for physical, so if you go physical hardware to Azure Site Recovery, think about just the technical challenges of taking a physical kernel box and wrapping that up and sending it over a wire and then standing it up in a virtual space, right? From a technical perspective, when you start really thinking about that, it's really impressive, but there's probably a ton of work there. So much so that it's almost impossible to account for. So what we actually do from a physical perspective is, if you go physical to ASR, we convert, once you have that data set up into ASR, into Azure Storage, we convert that physical data to a VM, to a VMware VM. Interesting, right? The big limitation factor there is if you do decide to fail back, let's say your system gets up and running, you replace the racks or whatever it is, you cannot fail back from from a VMware that's come from a physical back to physical. Because again, think about the technical challenges that's heavy duty. So you have to fail back into a VMware state, which can be challenging, right? So you have to plan for that, especially if you're a Hyper-V shop. But it's better than not having any physical failover at all. So we do support things like encryption at rest. So just data in your Azure storage location is encrypted by default. We have the ability to decide from a storage perspective that actually that Azure uses to ramp up your, whatever it is, your SharePoint or your SQL environment. We have the ability to decide what type of disks in Azure we want to be created when we stand those VMs up, right? So you might not want to use standard storage in your SQL box that is powering SharePoint, right? You might want to use premium, which for those who don't know, the difference is really just standard disk, spinning disk, versus like an SSD, right? You probably don't want to have your SQL environment running off of a spinning 5200 disk in your Azure data center at that point, right? So you have the ability to define, well, this is my web front end, I want this type of storage, but my SQL box gets premium, and maybe these application servers, this one's doing search, so it's going to require a little bit more, or this one's doing, workflow management or whatever, so it's less. You can dictate all those. So the level of configuration that you have once you're in Azure, you essentially have a data center at your disposal. When you're planning both network and storage, it really comes down to churn. It has everything to do with how much data is both being processed and being transmitted that dictates how you plan for that configuration. It's the same exact planning that you do on-prem. When you stand up an on-prem environment, you have to do all those things. You have to define what type of disk am I going to need, what's the server going to be doing, how does it interact with this one, and what's going to be the IOPS across those, right? So you have to understand that. And the same thing goes into play with Azure Site Recovery when you're standing those up. One other thing that I'll call out that's on here that you guys probably just define a little bit. We have a 1 terabyte disk limit. You can have 64 disks in a VM, but if that disk is physically 1 terabyte or more, it's not supported unless you're using Store Simple, which is another aspect of some of our features that we offer. But if you're not, and you're just using traditional at that point, it has to be 1 terabyte or below. It's worth calling out because in this day and age, we're getting some pretty big data sets on disks that are worth talking about. So, in a nutshell, this is essentially what happens. It's the most generic graphic of all time. You take a VM, you send it over the wire, and it's in Azure. That's essentially what we're talking about here. I'll talk through the nuances of that, but at base level, if you're just explaining this to somebody, you're just standing up a VM in a different place, okay? So let's talk about how that works. Again, I'm going to be talking about this from a Hyper-V perspective, not a VMware. The install, the configuration is identical. So don't get hung up on the technology. We'll talk about physical as well, and that sort of covers the bases across those two. But again, don't get too hung up on that. So the first thing we're going to do in Azure is we create what's called a recovery vault. This is sort of a bucket or a container that we house the entire backup strategy in. And you can have multiple vaults. This thing gets really spiderweb really quickly when you start taking in, if you wanted to. That's probably a better way, right? It doesn't have to be. It can be very linear. If you're only backing up one single, let's say, SharePoint environment, you have one recovery vault, you have one Hyper-V site, et cetera, et cetera. But if you have things like multi-geographically dispersed locations where if that location fails over, you have to pick the closest data center to that location for data residency issues or connectivity issues, this thing can go really deep really quickly. It just depends on how complex the environment that you're working in has to be. You create what's called a Hyper-V site, which I personally don't like the naming convention of, but it's yet another bucket in which this particular workload, this group of VMs, are going to be housed into. So it's one level deeper than your recovery vault at this point, okay? Next thing you do is you're defining what type of failover this is going to be. So it's either going to be Hyper-V, physical, or VMware. And when you choose, let's say Hyper-V in this case, you get presented a screen that has download in it, and it has a key in it. So that key is an encryption key that's tied to that recovery vault, that's tied to, that Hyper-V site, where it's an encryption process where you're actually doing the configuration on the Hyper-V host. You have to say, I want you to apply these VMs to this thing that I have in Azure, and this thing in Azure is going to go, wait a minute, do you have the recovery key, or do you have the key itself? And we say, well, yes, I do. And it's this huge hash that we have to, we save it to a file, and we can dump it into where it's asking for, and I'll show you that here in a second. But it also will let you download, based on what you've chosen, the bits that you have to install on that host. Whether it's physical, that's a different process. If it's VMware, you're putting it on the VMware host. If it's Hyper-V, you're putting it on the Hyper-V host. So once I do that, my first graphic here is now I'm on my machine. I'm on my VM or my Hyper-V host at this point. I'm defining what it actually is. By the way, we're going to show a demo of this walkthrough live. Not live. It's recorded because it's trimmed down, because you don't want to sit here and wait for SharePoint environments to be sent over the wire, I don't think, with conference hotel internet. So I've sped it up. I've trimmed out all the nonsense and the waiting times in between, and I've taken basically a 3-hour process and made it 7 minutes. So I'll show you how all this works. It's the best I could really do for you guys. Nobody wants to sit through that. All right, so your bits get dropped on the host. Again, you're defining what the key is. You're doing some other configuration, making sure like the region in which you're in is where that physical box is you're tying that to the physical region of the data center in which you want it to be applied to. Any kind of smaller nuances that we're dropping on the box to handle the processing of those synchronizations. We jump back into Azure and we select our target subscription. You might have multiple multiple Azure subscriptions. In some cases, most cases, you have one, but you might have multiples, again, depending on your business. Maybe you have acquisitions that they have Azure subscriptions where they have things running in it, but they're in Japan and you're in US. Again, the different elements can be almost infinite at this point. We're then creating our replication policy where we're defining, out of the boxing matches with management and funding people that have come from how much do you want to spend and how much do you want to lose, this is where that gets defined. How fast am I doing my replications? How often in between the data syncs am I going? And how fast I want them to be brought back up. That all has a cost associated with it. And that cost goes back to the conversations that you had, which then lets you fill in the blanks here. Very benign. It's like 10 blanks that you have to fill in, 10 fields, but they've come hopefully from a lot of conversation at that point. All right, so now you define which recovery policy you're attaching this to. So you're tying this back to the Hyper-V site in which your VMs will essentially live at that point. You'll choose a target subscription and a resource group. So resource groups are new to Azure. We'll talk about those maybe in a couple other sessions, but not in this one. It's just a placeholder essentially for us. And then lastly, you will define, not quite lastly, but in this case, you're defining which, so you've already got this thing running on your VM host, remember? And it has that key, and it's made those synchronizations and said, hey, Azure, these are the VMs that are running on this VM host, and present them to the user, and then you as a user get to define which servers you're actually going to be doing that replication for. In this case, we have a SharePoint application server, database server, and web server. Remember I said we can do things like Linux as well. So we're not quite to the point where Azure can detect, I guess, what type of VM I'm actually wanting to bring over. It doesn't know which style of VM to stand up if we do failover. So one of the steps is line items for each of those servers and defining which type of operating system they actually are. You then tie the replication policy to that, and then lastly, you start your replication. So again, remember that you have all these configuration points afforded to you with how much data you bring and when, how much saturation you go, but essentially it's a job that's running that sucks in those VMs into Azure storage at that point. Now our recovery plan is essentially what do we do when we fail over? What things have to happen in what order, right? So we can create what kind of, the title of our replication plan. We can say these are the machines that they are applied to, but then the last step is what do we want to do when we actually click that one sweet button that just pops over and starts failing everything over. Maybe there's things that we have to take into account for that type of application or workload. Maybe it's not even SharePoint at this point. Maybe it's things like we want to stand up our database server first so that when our web servers come up and our app servers come up, they can see the database server exists, or not vice versa. Or maybe we want to activate a public IP at this point to make sure that we're swapping over to the failover network that we're using to do our actual failover. So you can define down to scripts. You can actually build scripts here to what happens to what VM in what order. Email the administrator, tell them things went completely awry and now everything's failed over to Azure, and go fix it because it costs a lot of money. So start working on the other boxes, or send an email saying, hey, our lift and shift actually worked. Like, we're up and running in Azure now, and everyone gets an email, whatever it might be. I mean, the sky's the limit at this point. Kind of makes sense? That's in a nutshell just the configuration process. Again, the custom actions, sorry, I was ahead of myself on one. So the custom actions is what that we actually call that. And then lastly, we're defining what type of virtual network we want to use when we fail over. So we can define, so one of the things, we kind of make it really sound really easy, but when you do hit test failover, all the things that had to have been in place already, like the virtual network that you want to use that doesn't take your current network offline to make the actual test an actual test. If you're using the same one, then your test failover is not test failover anymore. It's like an actual failover at that point. So we can define which network we want to use where, right? Again, this goes into play with maybe geographically dispersed locations. Maybe we're just testing one place or another. You have the ability to configure this almost to a fault. Okay. Shall we? You want to see how this thing actually works? So not the best presentation posture, but I'm going to sit down because I have to man the mouse and probably pause a couple times to tell you actually what's going on here. Otherwise, it's going to go really quickly. I've got it trimmed pretty good. All right. So this is my Azure subscription, and I'm doing that first step essentially where I talked about creating the replication or the services vault, recovery vault. Let's see here. All right. So we create a recovery vault. We get to name it what we want to name it. We can choose a subscription that we want to use here and the actual location. So that location should match the region in which the servers physically live, right? So if your data center is in California, you probably want to pick West US. If you're in Texas like me, this comes up as Southwest or South Central. I've created that. It does some validation. You can see there on the side it's completed. That actually took a lot longer than it shows. It's like maybe 3 or 4 minutes. So I've created that, and now I have my recovery vault. So I jump over to my recovery vault, and we've actually made it even simpler than even a couple years ago. So I've done this demo a couple times where we've almost made it step by step at this point, right? So if you go into your recovery vault, whatever you've named it, and you actually have the options at this point on the side to do a site recovery, and then once you select site recovery, it starts walking you through all those little snippet graphics that I showed you, all those steps. Like, you don't have to remember that. These things will just flow for you, so it can be a lot easier to understand. I gotta find my mouse again, there we go. All right, so I'm preparing the infrastructure. I'm essentially saying what type of machines are these? What do I want to fail over? Is this physical? Whatever it might be. And I'm just setting that basic elements down there. So now I'm creating the Hyper-V site. Remember, that's just the container in which these VMs are going to live in. And it's bound to the selections I just made for the architect or the infrastructure there. So I selected it's a Hyper-V site. I go and create my Hyper-V site, and this is that point in which you're downloading those bits, if you recall. This is like the worst experience ever for, sorry. Jump back up here. So you've downloaded these bits, and you actually have to install them onto your VM host at this point. So let me jump back to where I was, sorry. Pausing this thing is not super awesome. So I got my key. One of those bullet points was the key, and I'm browsing to that key location here. And then I've actually started the install. So this is what's called the process server. We're essentially just creating the synchronization connection between your VM host up to Azure Site Recovery. So that gets done. It's pretty straightforward, pretty quick. I get the fully qualified there, so I know that I've made that connection. Now again, I'm going through that subscription, just choosing the subscription that I want to use, and then I'll choose my resource manager or classic. You can choose either one. Our recommendation is obviously going to be the resource manager. Now we're just creating our policy, right? This is where all the RTO, RPO things come into play. Give it a name. We've already filled in some of the blanks for you because of what you've chosen. The frequency in which you want to do those backups, how often you want to go in between them, and then actually setting that up. So there's let's see if I can find the button fast enough here. There's a planning, a capacity planning tool I'll show you here just a bit. We're looking pretty tight on time, but we'll see if we can squeeze it in. Where a lot of the information that you've chosen and the inputs that you've made go into some of the decisions that you've picked with your RTO and RPO, and you derive that from, these are the VMs that I have, this is what I wanted to do, and it tells you essentially what cores to set up and how many disks to use and which disks for which servers. We can tell you most of that. You know, obviously there's human intervention that needs to happen there to make sure that you're choosing the right things, but that does come into play. So now I'm actually making the replication application. I'm selecting my subscription again. Most of these things are already in there. One of the things you didn't see is me create all the network components, right? So I'll select that down here at the bottom. That'll be one of the first things that you'll want to configure when you, unless you already have, right? If you already have an Azure subscription, you have your networking all configured, and nothing has to change for your Azure Site Recovery aspect of it, then you're pretty much golden at this point. But if you haven't, then you need to go through and choose which networks you actually want to use when you do a failover. So now I've reported up, the jobs have run, and it sees which boxes I want to create or replicate. Now I'm choosing which servers the OS types are and which kind of boxes they are. I need to take out some of the naming conventions because we don't support underscores at this point. So you'll see at the end, I'll just drop out the underscores out of those names. That's why they're all lit up. I can decide here as well which things within my servers to not synchronize, right? So temp DBs, I can say, I don't want that, right? So it just saves you on the amount of data transfer that you have to actually do. Let's take out those. All right, so I get all green, I'm ready to go. Just a recap of what is actually being configured. The replication is going to start immediately. I'm looking at 24-hour recovery points, and they're happening, I think I saw like every 15 minutes or so. So these are the jobs that are actually running. You'll want to keep track of these while you're doing your configuration just to make sure that they are complete before you do any kind of like test failovers or anything, because These complete at different times, at different rates for different locations. So you want to make sure all your jobs are completed and then all your VMs have been replicated and are protected on the Azure Site Recovery side. And you can see that I have my 3 that I've created there. So now I've got the VMs over, they've replicated. Now I actually want to do my recovery plan. What actually happens when I fail over? So again, I select the name of what the recovery plan is going to be, which servers are going to be protected. And now I'm going through that customization process where I'm defining which servers are starting up first. Do they have any scripts that are associated with them? Dragging and dropping essentially is the interface here. So I can define all that very, very deeply into how I want all those things to actually work. I can group them, ungroup them. You can have multiple farms at this point failing over. Don't think about this as just one 3-server farm. You might have a load balanced farm. Might have a geographic or like a stretch farm even these days is still possible. So a lot of things can actually be happening within that customization screen that was very benign in this example. So I'm choosing which network I want to fail over to. And now I'm just going to test my failover, right? I'm choosing what network I want to use, what recovery point I want to process, whether that's the last one or multiple RTOs from in the past, and it's literally a one-click process at that point. So all the things will happen, all the VMs will get stood up and moved from Azure IaaS or Azure Storage over to Azure IaaS. You'll see all these VMs spinning up. You'll start incurring costs immediately, and then you can, at the end, when you want to complete the failover, you can actually say, stop and delete all of my VMs. Now you're not deleting them from storage and this entire process that you just did, you're just deleting them out of Azure IaaS, turning them off, decommissioning them so you're not incurring any additional costs at that point. So everything that I just did, I actually set up my failover, I tested my failover, and then I destroyed all the things that are going to cost me money after the fact. So if you're following any kind of certification process that requires you to do these things, those last like maybe 10 steps of maybe a minute worth of that video, that's your certification process. Just click it and you're done. If it fails over, you can test it, you can navigate it, see it's working, do all the certification components, and then complete fail back, or not in this case, you wouldn't fail back because you hadn't failed over, but you've done a test failover, stood up at that into that other network, stood up all your VMs, and then crushed them back down again. All right, so I thought I was going to have way more time for questions. Now I'm coming up against the wall here, so I get to talk, and you know how that goes. Let's maybe go through some of the physical stuff. I'll breeze through what that actually looks like from the installation process too, because that's one of the only things that's kind of different here. Configuration server is required on-prem. Okay, so if you do physical to Azure Site Recovery and you want to do failover here, you actually have to have a server or one of the boxes that you're working with acting as that replication gateway. It captures all those things, does all your checks and balances to make sure you're sending it to the right place, manages the process server that handles that handshake, and then actually sends that content over. It's the only thing that's really, and the VMware failback thing, that is different from any of the process. So there's actually a physical thing you have to stand up from a machine perspective at this point. We talked about failing back from physical, has to go VMware. Again, a little bit wonky, but that's the way it works at this point. The mobility service will actually be configured. It's an additional step. You can install it a couple different ways, UI, PowerShell, those types of things. You can even System Center push everything. By the way, you can do all this in System Center if I didn't call that out. You don't actually have to do any of this manually if you don't want to. So if something does fail, like a heartbeat check, System Center can manage all the failover. This is what the physical to Azure replication architecture kind of looks like. Remember I called out that the process server and configuration server can be combined, and those are physical things that have to exist to make sure that you're replicating your physical boxes. When you're going Hyper-V to Azure Site Recovery, all these things are essentially taken care of for you. Obviously, because it's native technology, at that point it's easier to account for. But it's just slightly different with Azure, with physical to Azure. Real quickly, this is what the installation of that configuration server looks like. I'm not going to be the one who talks through every single slide of a UI install, but this is essentially what you're looking at this point. So you're going through the steps. It's very self-explanatory. You're choosing those keys again, right? So it's mimics a lot of the VMware, or I'm sorry, the Hyper-V install. Well, VMware for that matter as well. Where it starts to get a little bit different, you can define your network ports and things like that, right? So there's a lot of different URLs and ports that you have to make available in your firewall to make all this work. This is where those correspond back to the configuration process. We document all those. It's actually pretty easy. There's only 2 ports, but there's a lot of URLs. This would be the same exact thing as those jobs that we're running in Azure, right? When we said, okay, go, start, and start doing all our replication jobs. And you can see, and I said, make sure that you're monitoring them, right? These are the same thing from a physical perspective if you're doing physical boxes. We do install MySQL on this, so you have the password and configuration there, where you actually want it to install, et cetera, et cetera. You get the point, right? So I talked about planning is a major aspect of this, and unfortunately, I saved the major part for the end of the deck, and we run out of time. But the point of it is you have to take this back and say, okay, I know I want to use Azure Site Recovery because obviously it's easy. And for the record, I know I kind of kid a bit that it's expensive. It is in traditional sense, but is way, way, way cheaper than any other third-party replication disaster recovery product out there. I promise you, by a lot. So this would be the first place that I would check, make sure that it accomplishes all the goals that you want. But when you're doing this, again, the churn rate and IOPS and network config is where the majority of this configuration actually happens, because if you go to obviously do your failover and your network doesn't support it, or you have slow disks, like the customers are going to know that you failed over because something changed, because SQL's taking an eternity to actually respond. So in classic form, we give you an Excel workbook to do all your network and storage planning. The inputs are pretty self-explanatory. The outputs are much nicer, right? So we can define, hey, this is what your workload looks like. This is how many cores you're going to need allocated to this failover, what type of machines it's going to require. And then you take these and you can run against the price check within Azure to make sure the costs are what you said it was actually going to be. So we give you essentially what to build. We show you what to go price out, and then you can tweak those numbers as you see fit. So a couple important notes just coming down to the wire now. You need to have as many cores available in each target region to support the VMs you're going to fail over, right? So if you don't have those cores available in that subscription, in that region, when the failover actually goes to happen, it's going to go, I don't have enough, and I can't stand this box up because you didn't allocate enough cores. Right, so you have to make sure that those numbers match, and you almost have to reserve them to make sure that they never go unavailable, because if you actually do have a DR, you don't have the cores, you can press that button all day, nothing's going to actually happen. I told you about the process server, so I went really quickly by the hardware requirements of that process server. It was something like 8 cores, 16 gigs of RAM, et cetera, et cetera. That changes based on how much you're pushing and how frequent. That's the minimum. You could actually have multiple servers just handling the handshakes at this point. So physical to Azure Site Recovery actually gets pretty complex, and then you actually have an infrastructure alone just for the failover of your infrastructure. So take that into account. There are checks that you can do in Azure Site Recovery that monitor the status of your VMs. You want to make sure that the VMs are in good state. They've replicated. There's no configuration errors. There's no data sync errors, because again, you can press that button all day long, but if it stands up and nothing happens, it didn't matter. 2 ports for making all this work. 443 is our sync channel, and 9443 is our data channel. So you'll have to make sure those are clear. Most 443s are. And then the URL list, there's a whole bunch of URLs that you have to make sure are open for this to work. So let's wrap it up. Again, focus your energy not on the configuration of ASR. This very easily could have been like a session on how to set up networking and storage optimization to use Azure Site Recovery to fail over SharePoint. And it could have been very easily that way. That's going to be the majority of your time and energy. Just make sure you spend the time in doing that. Again, setup as ASR is really easy. Have that cost to simplicity to reliability conversation, right? You can usually only pick 2 kind of thing. Make sure that they leadership and the folks who are writing checks know how much this is going to cost for what you're essentially giving them, and make sure that they understand that you want 0, it's going to cost way more than 0. If you are flexible in what your RTO and RPO needs are, then the cost differs as well. Just understand what those SLAs are. One thing we didn't talk about too much was how this option could really work well for geographically dispersed hybrid to SharePoint Online scenarios. Again, that express route thing gets a little bit shaky in there, because we're not really suggesting using express route with 365 anymore. Depends on which type of tenant you're on, but I can go into a rabbit hole on that one as well. But this is a pretty good option to that if you can exclude the express route. So if you want a really fast SharePoint environment and you don't want to have any physical data centers anymore, and you have people all over the world that need to access this stuff, and you have features in SharePoint Online that you need and stuff in SharePoint On-Prem that you cannot give up, this is a perfect scenario to run both of those and getting your environment over into Azure without doing all that heavy lifting. And then again, this is actually true one-click failover and failback, with some caveats actually, but you can still do it, and the amount of time that it takes you to actually test it and be confident in those testings to be able to say, yes, I know that when my job is on the line and everything goes south, that when I hit that button, all the work is actually going to pay off, and we are going to fail over, and we're not going to lose service into those SLAs. Okay, so I know that was a lot at the end. Hopefully the deck will give you more. There is a ton of documentation on this stuff. You can go out and do test videos. There's a bunch of blogs from the product group for ASR. It's a very small product group, so they're a lot more willing to help if you have questions. So reach out to them. Obviously, you can always reach out to me. Hopefully you guys have a great conference. Hang out if you want to chat more and ask questions. I don't mind. Thanks for having me.